So today we will continue multiplication in polar form for the complex number, as we already go through before this. Okay, kita dah tengok polar form kan. So remember polar form for complex number is z equal to a plus ib is a non-zero complex number. So theta measured by angle from the positive real axis. So I just go back for our refreshment. Polar form is in form. Polar form is in this form. For complex number, z equal to a plus ib, and theta measured from positive. Then we also know that r equal to modulus z, and we can change this polar form into in terms of r cos theta plus I sin theta. Okay. Then theta itself is argument of z, and then we also already go to this quadrant: first quadrant, second quadrant, third quadrant, and fourth quadrant. Then we can find that theta is equal to argument z, or equal to shift tangent or inverse tangent y over x. Okay. Now we go to multiplication in polar form. So before this, we already remember that polar form is one of the question that will be asked in final or test. Okay, so hopefully you take note of the polar form. In multiplication in polar form, so let z1 equal to r1 cos theta 1 plus I sin theta 1, and z2 is r2 cos theta 2 plus I sin theta 2. So this one yang kita tengok kan, yang kita tengok ni adalah benda yang sama dekat atas tadi. Okay, at the first one. So z is equal to r cos theta plus I sin theta. This called as a polar form. Okay, dalam polar form dia ada theta. Ini kompleks number yang kita tahu. Ini adalah untuk polar form. Kompleks number dalam bentuk polar form adalah r cos theta plus I sin theta. Lepas tu, from here, due to we have z1 and z2, so it is depends on z1 and z2. So they have a r1 theta 1 and r2 theta 2. So bila kita buat multiplication, so this z1 multiply by z2. So that's why we obtain here z1 z2 is equal to r1 cos theta 1 plus I sin theta 1 times or multiply by r2 cos theta 2 plus I sin theta 2. So after we do this solve this multiplication, so this equation we susun balik r1 r2, then kita buat dalam bentuk ni. After that you multiply this cos theta 1 and to cos theta 2, I sin theta 1 to I sin theta 2, and so on lah. After that, after you susun all ni contoh so you will get cos theta 1 cos theta 2 plus cos theta 1 I sin theta 2 plus I sin theta 1 cos theta 2 minus sin theta 1 and sin theta 2. So daripada sini yang warna pink ni ada satu yang kita susun balik. Okay, bila kita susun balik yang warna biru ni dengan yang warna biru ni, so kita akan dapat cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 dengan yang warna pink ni. So it actually a identity of trigonometrics. So the identity of trigonometry adalah cos theta 1 plus cos theta 2 adalah yang warna biru ni. Yang ni tadi, yang biru ni. And sin theta 1 plus sin theta 2 adalah yang warna pink ni. So that's why you simplify this equation yang you dapat into this trigonometric identity. So then you get R1, R2, kat sini R1, R2. So cos theta 1, theta 2 plus sin theta 1, theta 2. I sin theta 1, theta 2. Sebab apa ada I? Sebab kita susun komponen I satu, ni yang tak ada komponen I. Okay. Komponen I warna pink, komponen biru ni yang tak ada I. Imaginary number tu kan. So you get this equation Z1, Z2. Ni to show that Z1, Z2 modulus equal to modulus Z1, modulus Z2, and argument Z1, Z2 equal to argument Z1 plus argument Z2. So secara mudahnya, bila Z1 plus Z2 ni, you akan dapat actually ini equation dia lah. R1, R2 cos theta 1 plus theta 2 plus I sin theta 1 sin theta 2. So kalau ada question, kita just masukkan saja. Theta ni berapa, theta 1 berapa, theta 2 berapa, R1 berapa, R2 berapa. Okay. So then you show that Z1 ni adalah equal to Z dot Z1, Z1 dot Z2 equal to modulus 1, modulus Z1, modulus Z2. Dan argument tu sendiri, argument adalah theta kan. Argument Z1, Z2 equal to argument Z1 plus argument Z2. So example, so dia bagi kat sini find Z1, Z2. So it asks you to find Z1 and Z2. Z1 times Z2 lah. Multiplication kan. So what is Z1? Z1 is 1 plus I square root 3. Z2 is square root 3 plus I. So ni dalam bentuk complex number kan. This is in the form of complex number. This is in the form of complex number. Now you can find what is the value of R. Kenapa kita perlukan R? Because polar form for this complex number, still remember Z equal to R cos theta plus I sin theta. So ni dalam bentuk complex number. So we need to change this complex number into form of polar form, which is Z equal to R, yeah, Z equal to Z equal to R cos theta plus I sin theta. This is dalam bentuk polar form. So daripada equation yang ni, complex number, kita tukar kepada polar form. That's why you need to find R value dengan you kena cari theta ni berapa. Theta adalah cara dia macam ni. Theta is equal to inverse tangent B minus A. Okay. Now we go to the question back. So you are given this Z1 and Z2. Now you find the value of R. Okay. So R is actually equal to Z, modulus Z. So modulus Z adalah, cara nak cari modulus Z, tengok balik nota yang tadi. It is, how to find Z, still remember? Okay, modulus Z, square root of 1, A and B kan. A squared plus B squared. So you square root all this value, then you will get the value of R is 2. Okay, you must remember how to find the R value first. After you find the R value, what you need to do? So you have Z should be equal to R cos theta plus I sin theta. Okay. So you already find the R. So you need to find the theta. So when you find the theta, here the theta is actually equal to arc z. Okay, argument z. Argument z is equal to this tangent inverse tangent y over x. So where is y? The equation here, square root y, x is 1. So inverse tangent square root of 3 divided by 1. So you get this value 60 degree, or in radian you get pi over 3. Okay, remember this pi is equal to 180 degree. So the polar form for Z1, ni baru satu ni baru Z1. For Z1 adalah dua ni you dapat the value of R, this is value of R, this is theta. So this is the value of theta. The value of theta in radian. The value of theta, so lengkaplah you punya polar form in term of complex number in term of polar form for Z1. Now you need to find the Z2 pula. Z2 you have square root 3 plus I, which is 1. 1I lah. Okay. So find the Z2. So Z2, again, Z2, find the R value using the equation. Then you will get the value of R is 2. Okay. Then go to find the arc tangent. Arc value, which is theta lah, Rz. By using this theta equal to Rz equal to inverse tangent y over x, where y is 1 and x is square root 3. Terbalik tadi kan? Sebab apa? Tengok value yang polar complex number tu z equal to a plus ib kan? So which one is x, which one is y? Okay, so this is x and this is y. Still remember kan? Ingat kan kalau kita buat graph, ini adalah imaginary, ini adalah real. So ini adalah A dan ini adalah B. Ingat value of I dengan value of B. So your X is square root 3 and then your Y is 1. So then after you use you get also the same value, 30 degree, and you have y over 6. So you should get the polar form for this Z2 is 2 cos pi over 6 plus I sin pi over 6. Okay. So what is the difference? Here is pi over 3 for Z1. The theta here is pi over 6. Now you have two complex number in the form of polar form. Z1, this is the complex number for, so this is Z1, okay, in terms of complex number in the polar form, and this is Z2, okay. Where actually in the complex number, dia equal macam ni kan? Okay. So, Z1 equal to 1 plus square root 3 tadi kan? So, Z2 is Z2 equal to okay, Z2 saya kat tak ada whiteboard ni. Z2 equal to square root 3 plus I. So, ni dia punya nilai in term of complex polar number. Polar form complex polar form of a complex number. Okay, complex number dalam bentuk polar form. So, baru settle kan? Nampak tak dia punya step? You can see the step. So, actually, you can see the step from this. From this complex number, you derive into complex number in terms of polar form. Then you get this equation. Then now you use the equation Z1, Z2 multiplication form. So we go to multiplication form. Z1, Z2 equal to R1, R2 cos theta 1 plus theta 2 plus I sin theta 1 plus sin theta 2. So this is the formula for multiplication form for complex number, for polar form. And then after you multiply this, you just masuk je nilai tadi kan. R1 2, R2 2. Theta 1 pi over 3, theta 2 pi over 6. Masuk. And then 2 times 2, you get 4. Pi over 3 plus pi over 6, you get pi over 2. Same goes to this pi over 3 over pi over 6, you get pi over 2. Then you get this value of Z1 and Z2. Multiplication form, polar form for Z1 and Z2 is 4 cos pi over 2 plus I sin pi over 2. So as a check, we calculate that Z1, Z2 directly without using polar form. Kalau kita nak check betul tak kita punya jawapan ni, kita boleh guna direct form, direct complex number, tak perlu guna polar form. So kalau you guna calculate Z1, Z2, Z1 multiply by Z2 ni dalam bentuk complex form biasa, complex number biasa ni, so you get square root 3 plus I 3 plus I squared square root 3. So still remember I squared equal to negative 1. So here you get negative square root 3 because of I squared is equal to negative 1. Okay. So I squared here is equal to negative 1. So that's why you get negative 3 here. Then you boleh cancel out 3 here, cancel out negative 3 here. Then the balance you get is I plus 3I. So I plus 3I you get for 4I. Okay. So you get the 4i's. It is same with this part lah, 4I. So as you check, the value of complex number without using the polar form is 4I, and this is with using the polar form. Okay, so that finish for multiplication. So multiplication, dia punya step you kena remember macam tadi lah, step-step dia. Kena cari R dulu, lepas tu cari theta, after that in terms of multiplication, then you find this answer. Okay. So to check your answer, you can use complex number yang tak without using the polar form. Okay. Now we go to second part which is division in polar form. Tadi multiplication, sekarang kita pergi ke division. So division adalah bahagian. Division adalah pembahagian tu. So sama juga in polar form, kita tahu bahawa Z1 is equal to R1 cos theta 1 plus I sin theta 1 and Z2 is R2 cos theta 2 plus I sin theta 2. So if Z2 is not equal to 0 lah, kalau dia punya value ni tak equal to 0, baru dia boleh buat in division. Kalau Z2 is 0, you tak boleh divide. Okay, Z1 tak boleh divide dengan Z2. Okay. Kosong kan? Alright, so now to find the division, tadi multiplication Z1 times Z2 kan? Multiply Z2. So now Z1 divide by Z2. So benda yang sama juga. Okay, benda yang sama. Just masukkan balik the equation. Ni untuk show to show you how it is work and what is the formula for Z1 divided by Z2. So and then you multiply all this part. Okay. Multiply by the denominator, the conjugate for the denominator. So you get that cos theta I sin theta 2. Yang ni pun darabkan conjugate of the denominators cos theta 2 minus I sin theta 2. So bila you multiply the conjugate tu, and then you cancel out the one that can be cancelled out. Lastly, you will get this equation. Okay. Lastly, we get this equation, and remember, cos squared theta plus sin squared theta equal to 1. Okay. So yang bawah ni cos squared theta plus sin squared theta adalah sebenarnya 1. So kat bawah sini adalah you cancel out, you tukar jadi 1. So bila tukar jadi 1, tinggal yang atas ni sahaja kan. So that's why you get R1 R2. Okay, R1 R2 sebab dia bahagi kan, R1 R2. Kalau multiply R1 times R2 kan, ni R1 divided by R2 cos theta ni, equation ni, this equation. Okay, cos theta 1 cos theta 2 minus I cos theta 1 sin theta 2 plus I sin theta 1 cos theta 2 plus sin theta 1 sin theta 2. So again, identities for the trigonometrics, you can susun dia in term of imaginary part yang blue color, and pink color is the real number, real part. So this part is equal to cos theta 1 minus theta 2, and this imaginary part you get sin theta 1 minus theta 2. So you masukkan balik dalam equation, you get Z1 divided by Z2 is equal to R1 divided by R2 times by cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. Okay. So you get Z1 over Z2 modulus equal to modulus Z1 over divided by Z2 modulus Z2. Sama juga dengan argument Z1 over Z2 equal to argument Z1 minus argument Z2. Okay. So that is the difference between multiplication dengan division. The value of theta inside here is negative, minus minus. Kalau multiplication it is plus sign. And R1 times R2 cos theta 1 plus cos theta 2 ni pun plus theta 1 plus theta 2. Okay, argument ke situ pun plus, yang ni argument dia minus. Okay, now you can try this example. I think all of you have the slide kan. Okay, try to do this example. So Z1 is given to you same. It is same with the first example. Cuma tukarkan dia punya konsep daripada multiplication into apa nama tadi? Into division. Okay. Multiplication into division. Okay. Sekejap saya kena pause bentar. Okay. So we look back into this part. So Z1 equal to 1 plus I square root 3, Z2 square root 3 plus 1I plus 1I lah. So sama juga, still remember dia punya equation tadi kan, in terms of polar form of Z1 and Z2, just masukkan je lah value dia kan. So bila you dapat value tadi, theta tadi untuk Z1 is pi over 3, theta untuk Z2 adalah pi over 6, R adalah 2 untuk R1, R2 pun 2. So masuk dalam equation ni, so you dapat 2 divided by 2, masukkan nilai cos dengan theta 1, theta 2, I sin theta 1, theta 2, then 2 divided by 2, you get 1, then cos pi over 6 plus I sin pi over 6, then just solve this part, which is you get cos pi over 6, you get square root 3 over 2 plus I 1 over 2. Then you can check by using complex number saja, not using the polar form. Okay. Okay. Sekejap sorry ada gangguan. So then kalau you check guna Z1 over Z2 ni guna complex number saja, without any using polar form, then you will get the same answer. You will get the same answer as this part. Okay. So 1 plus I square root 3 divided by 3 square root 3 plus I. So you darabkan and conjugate the numerator ni. Square root 3 minus 1 minus I1 minus I, and then you potong mana yang patut, and then finally you will get the same answer without using polar form sama dengan polar form punya part. So itu cara you nak check lah whether you punya jawapan tu betul atau tidak. Okay, so division dengan multiplication benda yang sama, tapi yang berbeza adalah dia punya minus ataupun plus, okay, sign dia. Okay, it's not sama lah, tapi sebenarnya dia punya cara tu lebih kurang, cuma dia in term of minus dengan positif part tu So that we finish for the polar form in term of division and multiplication. Now we can go through to the Mohd theorems. Okay, the Mohd theorems. The Mohd theorems. Okay. So the Mohd theorems. So if n is integer positive, so z equal to r cos theta plus I sin theta in term of polar form. The Mohd in term of polar form. So you will get Zn equal to Rn cos n theta plus I sin n theta. So in term of polar form, complex polar forms, any tak kisahlah dia kuasa 2 ke kuasa 3 ke, dan integer ni must be in positive lah, dia tak boleh jadi Z kuasa negatif 4. Dia mesti Z kuasa negatif 5 equal to R power of 5. Okay, cos 5 n theta I sin n theta, 5 theta contoh. So this is known as the Mohd theorem. In special case we denote as R actually equal to 1. So bila kita letak R is equal to 1 in this equation, then you will get Zn equal to 1 power of n. 1 power of 7 or 100 pun still 1 kan. So 1 power of n cos n theta plus I sin n theta. So you will get the direct equation, you get cos theta plus I sin theta n, so equal to cos n theta plus I sin n theta. So for example, dia cakap express in the form of 1 minus I and Z equal to R cos theta plus I sin theta. So evaluate I minus 1 minus I power of 12. So dia cakap you gonna evaluate this form complex number ni. In terms of complex number, you get Z is equal to 1 minus I. So then you find the value of R. So the value of R using the formula Z modulus. So you get 1 power of 1 squared plus minus 1 squared, square root you get square root of 2. So ni adalah value of X. So this is X, this is Y. So this is value of X, value of Y. So by using, macam mana kita tahu ni fourth quadrant? You kena guna ni lah. X dia positif, X dia positif, Y dia negatif. So dia dekat fourth quadrant. So dia dekat sini. Betul fourth quadrant. So you kena tahu kalau ni first, second, third and fourth. So kalau fourth quadrant, using the theta value, theta by using the arc Z apa nama, equal to inverse tangent Y over X, then you will get negative 1 over 1 inverse tangent, then you will get the answer lah. Bawah ni you will get negative 45, and negative 45 is equal to pi over 4. Okay, in terms of polar form, you insert the value that you get is R is the square root of 2 here, Z equal to square root of 2 cos pi theta so ni adalah polar form PF saya letak PF ni polar form. Polar form. Now we want to be insert into the Moivre theorem, DMT. Okay. So this is the DMT form. Daripada polar form you dapat tadi. So okay, Z equal to square root 2 cos pi over 4 minus I sin pi over 4. Then using the formula to DMT, the Moivre theorem, so Z power of n equal to R power of n cos n theta I sin n theta. N berapa? Kan tadi dia bagi tahu express evaluate in term of 1 minus I power of 12. So 12 ni adalah n. So you dapat Z power of 12 equal to R power of 12 cos 12 theta plus I sin 12 theta. Okay. Then you masukkan value ni lah. Theta ni pi over 4. Masuk kat sini. Ni masuk kat sini. Pi over 4. Dan yang ni pun masuk dekat R ni. Then you will get in term of this value 1 minus I power of 12. Then you get this equation after you insert all the value. Then you cancel out this into this. You get power ni 2 power of 6. This one you get cos 3 pi minus I sin 3 pi. Then you get 2 power of 6 minus 1 minus I power of ni times by 0. So you will get 2 power of 6 is 64. Darab dengan 1. Sebab ni kosong. So you get the answer is 64. Okay. Boleh So di Mohd theorem untuk this is equal to negative 64. Boleh Untuk complex number 1 minus I power of 12 adalah negative 64. Okay. Right. So that is the de Moivre theorem. Simple je kan? Cuma dia kena hafal step dengan kena hafal formula how to express in terms of apa nama de Moivre theorem. Okay, kena buat mula-mula daripada complex number. Okay, complex number ini dekat pukul 10 lah complex number sampai and then polar form and then DMT de Moivre theorem. Step macam tu lah buat satu-satu. Okay. Now we go to the last part which is roots. Okay, roots. Roots for the apa nama de Moivre theorem ni we can for roots ni kita boleh guna de Moivre formula to obtain the roots for the complex number. Okay, if n the integer of n is positive and z is any complex number, then we define that any n roots for z to be any complex number as they satisfy the equation. So we denote as w lah for roots. W n equal to z. Z is any complex number. W is roots. N is integer. So w power of n equal to rho power of n cos n theta plus I sin n theta. And we know that z is r cos theta plus I sin theta in terms of polar form. Ni polar form. Polar form for complex number. Okay, complex number punya polar form. So we assume w satisfied the equation of w equal to square root of z n. Then Wn, w power of n is equal to z. Alright, w power of n here is equal of z. So rho n satu part. Kalau kita susun balik equation ni dengan equation ni, okay, these two equation you will get rho n sama dengan r. Okay, cos n alpha equal to cos theta. I sin n alpha equal to ni I sin n alpha equal to I sin theta. So we can see that rho n equal to r, ataupun kita letak rho equal to square root r n, square root n r, where square root n r denote as the real positive integer root of r. Okay, boleh pelik. Okay. So senang cerita, rho n equal to r, this part equal to this part equal to this part, and rho itself is equal to square root of value r power of n. Yeah. In order to have cos alpha n, which is cos theta, and sin n alpha is equal to sin theta, so the angle n alpha and theta must either be equal or differ by a multiplication of 2 pi k. So this part we letak dekat n alpha ni, actually theta tu plus dengan 2 pi k. K ni apa? K can be 0, positive minus 1, positive minus 2, until so on. So n alpha equal to theta plus 2 pi k. Actually, we can find that alpha itself is theta divided by n here, 2 pi k divided by n, you get this. So alpha tu, alpha ni nak cari sama dengan theta over n plus 2 pi k over n. Thus, the value of W equal to rho cos alpha plus I sin alpha are given by rho or W equal to rho cos alpha plus I sin alpha. Yang tadilah. So, banyak formula nak kena hafal Kena buat latihan banyak lah mana tahu masuk final ke test ke kan. The roots ni. So, saya pun nak baca buku pelik. So, Z square root n equal to R square root n times by cos of theta over n plus 2 pi k over n. Ni datang daripada mana? Ni apa? Ni adalah nilai alpha. Apa ni? Exam nanti ada bagi formula ke? Exam tak ada bagi formula maklumat. Memang kena hafal. Ni alpha ni alpha value. Ni alpha value. Okay. Ini settle. So, itulah. So, untuk complex number for De Moivre theorem, untuk dapatkan nilai roots for R, then you use this W equal to rho cos alpha I sin alpha, which is W to equal to Z square of n, rho equal to R square root power of n, then cos here alpha adalah nilai ni, I here, sin here, alpha adalah nilai ni. Ni je last formula dia. Dan kita boleh cuba untuk example ni. Okay. Now it's 10 a.m. Actually, we should finish by 10. I scared that some of you having a class after 10. So we try to finish up until this part. Ada semua yang ada kelas ke? Ada yang ada kelas tak pukul 10? Can we continue until 10:15? Okay, continue je. Kalau sampai ada kelas tak apa, you boleh leave. Tapi tak dapat attendance lagi lah ni. Tunggu saya scan for attendance. Ada? Oh, tak ada Okay, kalau tak ada tak apa. Okay, siapa yang ada chat sir? Okay. So, we try to finish by 10:15 hopefully. Now, example. Dia cakap kat sini, find the fourth root of negative 16. Since negative 16 lies on the negative real axis, we can use theta equal to pi as an argument. Moreover, ni adalah tadi dia punya formula kan? W equal to R, so on ni. So R, dia bagi tahu kat sini, dia bagi tahu kat bawah kat sini, the roots, the R value, the roots, find the fourth root of negative 16. Negative 16 adalah you nak cari the fourth root untuk, maksudnya W1, W2, W3 and W4. Okay, you nak cari W power of 4 ni. 1, 2, 3, 4. Now, dia bagi kat sini R value negative 16. So R equal to modulus Z, and this Z value equal to negative 16. Equal, when you modulus, you cancel out the negative, you will get 16. R value here is 16. So letak W, R here is 16. So how you get the polar form? So Z equal to R cos theta plus I sin theta. This is polar form. So ini adalah bentuk polar form. So Z itself adalah negatif 16. R ni 16. 16 tu dapat daripada modulus Z. R adalah modulus Z. So you dapat negatif 16 equal to 16 cos theta I sin theta. Theta ni dapat mana? Because this negative 16 lies on the negative real axis. Okay. Negative real axis. Jangan takut itu. So negative 16 so ni real axis, ni imaginary axis. So you get Z is equal this is very alright. So you get here negative 16 ni real, ni adalah imaginary numbers. So you have R value is negative 16. So Z, so you get the Z value is 16 lah. So equal to Z. Okay. Then dia bagi juga tahu tadi due to this part lies on the positive, positive, negative real axis. So theta here is equal to pi. Pi equal to 180 degree. Okay. Boleh faham kat situ dia punya tulisan. Saya tak beli pen. Okay. Next time lah beli. Alright. So that's why you get here R negative 16, Z is 16, theta is lies on this negative real axis, so theta is equal to pi. Pi is 180 degree. Okay. Now you insert into the polar form. So insert into this polar form. So R salah saya gini tak. Saya terbalik saya rasa. Jadi R Z tu adalah negative 16. Okay. Balik dah. Betul lah. Betul. Z. Lepas tu theta adalah pi. Okay. Now dia nak cari the fourth. The fourth root of negative 16. The fourth root of negative 16. So now you have W0. So W0 is R adalah 16. Masukkan. And berapa kita nak cari? Fourth. Fourth adalah 4 kan? 4. Okay. So letak kat sini 4. So ni adalah nilai R. So masukkan theta ni berapa? Theta adalah pi. Masukkan nilai theta pi and then 2 pi. K ni berapa? K adalah yang tadi. K nilai dekat sini. Because of W naught, W0, so K is 0, then you can cancel out sebab dia darab dengan 0. So yang tinggal adalah yang ni je lah. Satu dengan yang ni. Okay. Okay. Then you will get 16 square root power 4, you get 2 cos dengan pi over 4 plus I sin pi over 4. And solve the equation, you get 2 times by square root 2 cos pi over 4 is square root 2 over 2 plus I sin pi over 4 is square root 2 over 2. Then you just simplify the equation. You simplify this equation. Then you get this part. So this part in terms of Z equal to A plus B I atau IB. Then you get this part lah. Okay. Keluarkan sebab sama. Square root 2 I plus 1. Okay, I plus 1. So this is your W0 kan. Okay. Alright. Now you can do the same methodology. Okay, the same methodology. By changing the by changing this one. So for W1 W1 sini jadi 4 juga. So tukar 4, R 16. And then N berapa? N adalah berapa nilai ni? Nilai ni. So 4, nilai N 4. Yang K adalah nilai yang ni. Okay, nilai W1. So sebab dia W1, K adalah 1, 1. So you solve this equation. So you dapat 3 pi over 4 dengan 3 pun sama, 3 pi over 4. You get the equation here. The solution you get square root pi -1 plus I. So itu adalah W1. Now W2 pula, benda yang sama je. You keep repeating the same methodology. W2, N adalah 4, R adalah 16. So masukkan nilai N 4, 4, 4, 4, R 16. And then nilai K here adalah W2. So 2 ni tadi masukkan dalam K here. So 2 darab 2, you dapat berapa? 4. 4 pi over 4 tambah dengan pi over 4, you dapat 5 over 5 pi over 4. Same goes to this part. Then you solve this part equation, you get 2 minus 2 square root 2 over 2 square root 2 over 2. Then you cancel out, you dapat square root 2 -1 minus I. Dah berapa dah ada? W0, W1, W2. Perlu W3. Okay. Now we go to W3. So this is the fourth roots. Kita nak roots 4 kan? N adalah 4. So ni roots. So roots ni roots keempat. Tapi K yang ke-3. So kalau dia cakap dia nak roots tu 4, dia nak roots dia nak root tu 4, dia nak roots 4. So N dia adalah 4. Tapi K dia start from 0. So 0 until 1, 2, 3. So you have W1, W2, W3. So you have the value of K here. So ada 4 kan? 4 value of K. But K start from 0. Must start from 0. K must start from 0. K, second K, 1, third K, 2, fourth K is 3. So this is the last roots. Same methodology, just masukkan balik. N adalah 4, 4, 4, 4, 4. K adalah 3, 3, R adalah 16. Then you solve this equation. So you dapat 7 pi over 4, 7 pi over 4. Then you solve this part, you get this part. Then you cancel out here. So you get this part, and then you get the last final one. Square root 2 times by 1 minus I. Okay. So now you have 4 roots. Okay, the fourth root of -16 are W0, W0, this one, W1, this one, W2, this one, pi over 2, -1, -I, and W3, this one, square root 2, 1 minus I. So you can see here is the roots for -16, the fourth roots. Kalau dia asking you to find the sixth root, you kena tambah W4 and W5. Okay. I think it's clear, right? So let's say if the question asking you to do The fourth root, remember, fourth root means n equal to 4. Negative 16 is z. R is the modulus z. You get R is positive 16. K is starting from 0 until 3. Okay. Then the formula is same lah. Tak perlu hafal pun. Simple je kan. Okay. So the last part for the complex number is complex exponential. Okay, this is the last part for today. Okay. Complex number for complex exponential in terms of polar form, z equal to r cos theta plus I sin theta can be written more briefly as z equal to r exponential I theta. So this is exponential form. So kita ada berapa form? Kita ada form apa? Kita ada berapa form? First one we have okay. First, we have complex number. Then we have polar form. Okay. Kemudian kita buat PMT. Kemudian kita cari roots untuk PMT ni. Dan satu lagi, form kita ada in term of polar form ni kita ada exponential form. So, dalam polar form ni, mostly kita guna yang ni. Polar form ni dia ada di Moivre theorem, find the roots, and also ada sikit lagi exponential form. Okay. So, which link to the exponential and circular function? Circular function again is trigonometric. Exponential exponent I theta is actually the circular function in terms of trigonometric too. It is cos theta plus I sin theta. So E I theta is cos theta plus I sin theta. So tukar kat sini. Sama je kan? R cos theta plus I sin theta sebenarnya sama lah dengan form polar form. Cuma dia singkatkan, secara mudahnya disingkatkan untuk menjadi z equal to r exponential I theta. So I and theta saja. So ni exponential punya. Ini sama dengan polar form. Alright, example. Express 1 plus I square root 3 in the form of polar form and then exponential form. Ada dua kan dia suruh. So, complex number ni tukarkan dia kepada form of polar form and exponential form. Simple je kan? Macam mana? Complex number ni cari dia punya R value kan? R value untuk this complex number adalah square root the modulus z ni, R equal to z modulus equal to square root of 1 squared plus square root 3 squared, then you get 2. Then since it's x 1 and y is square root 3, so sama juga step dia, inverse tangent y over x, so you get for 60, you get pi over 3. So you boleh letak dekat sini, theta adalah pi over 3, r adalah 2. Senang kan, jawapannya adalah 2 cos pi over 3 plus I sin pi over 3. Dan tukar pula pada z equal to r exponential I theta. So, you dah dapat nilai tadi dalam bentuk ni, polar form. Just tukar exponential, letak 2 exponential I theta dia berapa? Pi over 3. dan you dapat jawapan in term of polar form dengan exponential form. So it can be proved that the complex exponent follow the same law of real exponent, so that it is Z1 equal to R1 exponential I theta 1 and Z2 is equal to R2 exponential I theta 2. Then you will get Z1, Z2, Z1 times Z2 equal to R1 times R2 exponential I theta 1 plus theta 2 untuk multiplication polar form. For division polar form, you will get Z1 over Z2 equal to R1 over R2 exponential I theta 1 minus theta 2. So the exponent follow the law of complex number for polar form. Same saja. Sama je. Just tukar dia punya ni je. Exponent kan. Dengan kalau multiplication tambah, kalau division negative minus. That's the end. And there are some engineering application where you will use the complex number mostly in fluid dynamics, quantum mechanics, signal analysis, and control theory. So control is mostly robotics, signal more on electronic part, quantum mechanics, and fluid dynamics is more fluid dynamics mostly kita guna lah kan. Okay. Ni example ni is more on electronic part. You ada ohm kat sini ampere dengan ohm. So boleh tengok last example here. The current in the circuit is 4 plus J2. Okay. Apa beza dia? Kita guna I kan. Sini letak J kan. So ni is real number, this one is imaginary part. 4 plus J2 ampere and the impedance is 5 minus J ohm. So what is the voltage? So solution here, voltage equal to current times by impedance. So in the formula solution, kita mostly kita mechanical tak go through, tapi kita akan belajar lah kan, electronics, engineering. So ini in term of application. So E equal to I dot Z, which is voltage equal to current dot impedance. So voltage equal to I adalah 4 plus J2 times 5 minus J. You boleh guna complex number multiplication kan. So bila you buat multiplication, you darab terus ni. 4 times 5, you dapat 20. J times J, you dapat J squared 2. Then J2 times 5, you dapat 10J. J, 4 times J, negative J, you dapat negative 4J. And then you will get the final answer 22 plus J6 voltage. Okay, kalau ohm law expressed in the equation, ohm equal to I voltage divided by current. Sorry. Balik. I is current kan. Current equal to apa ni? Is voltage divided by impedance. So where the current I in amperes and proportional to the voltage E in volts divided by the impedance Z in ohm, calculate the complex voltage in volts when the current in the circuit is 3 plus J2. So ditukarkan current to I ni 3 plus J2, then the impedance is Z2 equal to 1 plus J4. Nah, atas ni soalan lain, bawah soalan lain So you get the answer here, negative 5 plus J14B voltage. Okay, ni tapi next time mostly you need to focus. Okay, I think this is the last slide kan. Thank you. So the most part you need to focus is the the roots part, okay, the roots part here, the roots, then the DMT, D-molarity theorem, semua dah tu lah Kemudian polar form, division polar form, multiplication polar form dengan polar form tu sendiri. Okay, benda tu je lah yang you kena try to do a lot of example ataupun just study the slide and also do the example. Okay, so I think that is the end of our part 2 for complex number. Okay, so any question before we end our class? Any question? Okay, thank you. So we meet on Thursday. Okay, we will meet on Thursday 12 to 2 p.m.